All right, here is the video on the one project for the study of chemistry. So standards are probably not going to be something you'll read through. Objectives will be good to read through because they'll be what you'll be checking off your list as completing. So describe chemistry as a science, understand the classification of matter, identify the number of molecules and atoms in a chemical based on the formula, explore the relationship between energy and matter with chromatography, solve real world problems applying the metric system, significant figures, noting the level of precision, the scientific method, and graphical representation, visually showing the independent and dependent variable relationship. All right. So there is a lot of options when it comes to submitting this document. So you can actually give like a video like I'm doing where, you've created some sort of presentation. You're going to give an auditory version of your responses. You can do a PowerPoint. You could do a Word document. You can do a Google Doc. So on that note, this will come to you as a PDF and you'll just copy and paste over the questions or use like the question numbers to signify on the project itself what question you're answering. So you do want it to be organized so that I know what question you're answering. So I would highly recommend using some sort of indicator like that where it's like, oh, this is aspect 1, this is aspect 2, and so forth. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 are all parts that I guess this should say 1 through 10. Sorry, I copied this over from another class. Are all parts that are actual chemistry concepts. This A and B portion, they are graded, but they're non chemistry content parts. So like APA formatting, if you use outside sources, which some do require, you'll want to do a reference as well as an in-text citation. And then you'll want your paper to be organized with good grammar. I'm not a class that measures your level of grammar skills. So an AI tool like Grammarly would be a great opportunity to practice using in this course. In an English class, you don't use something like Grammarly unless a teacher tells you to, because some of their standards they do want to know what are your grammar skills without assistive tools, right? But we know in real life we do get to use assistive tools. So beyond building those skills on our own, we can learn how to use technology like AI ethically in a class like this when it comes to grammar. So that's something to consider. And there is, you can visit the AI policy. I did put a little bit in here. Regarding AI use, you may use AI, to help with your grammar and spelling. However, ensure that you are proofreading. Even something like Grammarly, half of it I don't use. So that is something to take a look at. It generates errors all of the time. You may also use AI to help you conduct research, find sources. Generative AI is something Google has automatically built in and on my Google Chrome. However, you may not use AI to generate the text or paragraph written. I did have a conversation with one class where he said, if you're having a hard time writing a sentence of your whole page, of your whole project, if you're just really struggling to get a sentence put together, trying AI options to look at different ways to write it, that's not a bad thing, right? Because you're looking at a sentence, you're struggling with it. It helps give you alternatives. And then you can do a combination of them. But right right? A whole text, a whole paragraph should not be included. Ultimately, it comes down to it. You didn't write it, so it's stealing that. We don't talk about plagiarism and cheating, or even AI use as plagiarism and cheating, but ultimately, all three, like unethical AI use, plagiarism, cheating, they all fall under this category where you're stealing somebody else's work, even if it's the computers, and you're documenting it as your own. If you are an ELL student, so English, an English language learner, then speech to text, or sorry, if you want to write in your the language you feel the most confident writing in, and then translate it with AI, I'm okay with that. Speech to text or text to speech would be okay. Because again, you would be using those as assistive tools. They're not creating work for you. Okay. Definitely have some typos in here. I got my new reading glasses, so I can tell. So for question 1, so this is where you're getting into the chemistry questions. So in your own words, define chemistry. That can be a sentence. Additionally, spend some time researching online a chemist's job you'd be interested in a short paragraph. So a paragraph's 3 sentences or more. So if you want to just write 3 sentences, that's fine. That's sufficient. If you want to write a little bit more than that, that's okay too. You are doing research for this one, so keep in mind that you should be having references and in-text citations for this. You're going to be summarizing the chemist's job and what you find intriguing about it. So why you think it would be an interesting job. So number 2 is building a visual model. So it can be like a web. That's what they use oftentimes in class, describing the classification of matter. Provide an example and definition in your own words of each type of matter. So if somebody asks you to describe those classifications you gave, what would it be? This is one where you could use the internet for it, but you don't have to. If you did, right, you'd want to do in-text citations references. Describe in a short paragraph, at least 3 sentences. I put that in there a lot, just as a reminder, because some people get overwhelmed when I say paragraph. I don't want anything that's like super big. Just the 3 sentences will be sufficient. The energy difference between a substance in the gas state versus the solid, or versus solid. So again, this is something where, if you can answer the question in 3 sentences, 3 sentences is enough. Obviously, if you feel like you need more to answer the question, go for more. This one you should be okay with content. Anything in the content, you don't have to put a reference down. So anything in the learning material, you don't have to do a reference for. Okay, so this one says, let A equal the day you were born. Caffeine has the following chemical formula, and A is the coefficient. So, for example, I was born May 14th. So my A value would be 14. Okay, so everyone's A value is going to be a little bit different. So everyone's coefficient will be different. So that's the first thing you have to identify. Well, yeah, I guess that's the first thing. But once you identify what your A value is, which would be this portion, sorry, you'll want to go in and you'll want to figure out, okay, well, how many caffeine molecules do I have? As a hint, this whole thing's caffeine. Caffeine's a big molecule. It's got a lot in it. That's a carbon, hydrogen, nitrogen, oxygen. So if this number outside of it was 14, remember that coefficient has to do with the number of molecules. And then the number of nitrogen atoms, because each of these elements are individual atoms that are bonded together to form all together a caffeine molecule. So atoms make up molecules. So there's 4 nitrogen automatically, but there was 14 caffeines. Well, if every single caffeine molecule had 4 and I have 14 of them, hopefully then you can look at the numbers from there. You'll be doing a little bit of multiplication. It's the product. I'm going to throw a math term at you. There's a hint. You need to justify or explain your reasoning for the number of each and why they are different or the same. Showing your work would be sufficient. I should probably add that here now that I think of it. Showing your detailed work. Some of us show our work and it's very simplistic, right? So we would want to show our detailed work to justify it. And then what other chemicals are present in caffeine? Might want to go rewind this recording a few seconds. Just kidding. Okay, number 5 has to do with the lab. If you didn't do the lab, I did a lab for you. I put it in the notes packet. Take a look at it. So obtain one of your chromatography lab experiment filter paper strips or the image of the final result. You can use mine. So obtain that from the notes packet if you need to. Identify the original color you started with. Provide a brief description describing the paper chromatography. So you're describing, this would be something that is covered in our content. Describe in a paragraph, so at least 3 sentences. Provide a brief description. This could be 1 sentence, by the way. So I tried to put those in so you know, like, if you did just do a sentence, it's okay, that it doesn't feel super overwhelming when you look at, oh my gosh, what's a brief description? Well, I don't know. Okay, C, describe in a paragraph, so at least 3 sentences, how the ink separated out and what implies about, or what that implies about the different molecules of color and their speed of travel through the filter paper. Remember, larger items move slower, but that also means they filter faster because they're not going to move out. And then when we look at the filter paper, they filtered out faster, but technically they're moving slower through the filter paper. Maybe I should say that again. Larger molecules move slower through the filter paper, but that also means they end up showing up filtered out faster because they don't go as far. Okay, chromatography. Oh, this is not spelled right. It's supposed to be spelled with an A or an O. Oh no. This is so one of the things with my eyes, which is kind of interesting, and now you're seeing it. And part of the reason why I think all of these spelling errors I didn't catch. It's an A. Is my eyes don't match up when they get pulled together to read. So what that means is the images don't match up right. So my letters don't appear together. So kind of weird, but all right. So chromatography can be used in food testing, drug analysis, forensic science, environmental monitoring, medical diagnostic, biomedical research, quality control, manufacturing, research chromatography in one of the areas. Provide 1 to 3 sentences summarizing your research. This would be one where you would be online. This one would require a reference and an in-text citation. So that puts us at, this one requires research because you're looking at chemistry jobs. This one requires research, but so far everything else should be in your content. So that's not too bad. If you were to return to and repeat the lab, how would you improve the lab and why? Identify one real-life application of chromatography. And you will likely need to conduct, oh, you know what? We're going to remove this part because we kind of do that above. I'll send you the updated version. Provide a definition distinguishing the difference between chemical and physical properties. Provide 2 examples of each. So that's 4 examples total, 2 under chemical properties, 2 under physical properties, and justify in 1 to 3 sentences why each example is appropriately identified as chemical or physical properties. So a justification, another way to look at that is you're going to explain your reasoning. You know, what the why behind where you place it. If you do research for that, then you would put in text citations and references here. But if you don't, then you won't. This one you can use your content for. A chemical reaction gives off X kilojoules of heat energy. Let X equal the product of your month of birth times your day of birth. So I use mine as example, times your year of birth. So mine got up to, I don't know why. 13 or 139,440. So we need to identify X kilojoules. So that would be the first part. The work I showed up here with my birthday would be the same thing you would do down here for number 1. You're going to convert kilojoules to joules. So that is a metric system conversion. And then you'll also convert the kilojoules, so what was originally in I, to calories. All right, number 8. A container has the volume of a golden nugget, or I guess I should read this. The volume of a golden nugget is measured to be 4.25 milliliters. The density of its contents is 19.3 grams per centimeters cubed. 1 milliliter equals 1 centimeter cubed. That's a conversion for you. Using the density formula, density equals mass divided by volume. What is the mass of the substance in kilograms? Hint, you will need to do some conversions before using the density formula and after. So by before, what I mean is you're going to have to take and convert milliliters to centimeters cubed. And then the last thing you'll have to do is it asks for kilograms, and you're gonna end up with grams. So you need to go from grams to kilograms. All right, number 9, in your own words, describe the scientific method. What is the importance of reconsidering our original hypothesis and returning for a follow-up experiment? Examples to consider. So these are just examples that deal with gases. So we have helium is a common gas we use to fill balloons. We also commonly use propane. Have you ever considered the danger of leaving a pressurized gas in the heat, or what may happen as the change in temperature occurs? Another example to consider is the air we fill our vehicle tires with. Have you ever noticed that between the changing seasons, the temperature, or the changing seasons or temperature, the pressure in your tires changes? You know why, right? That's kind of, this is background information. So the data in the table represents the pressure of a gas when you change the temperature. There's a correlation or a relationship between pressure and temperature. Plot a graph of the data using the blank graph provided. Draw a trend line and calculate its slope. So we can just draw a trend line actually, because some of this, actually, I think I'm going to leave what it's got there because that'll help you. So how are the variables related? So if we think about X and Y, or what's the input and what's the output variable? Does one depend on another? Are they independent of one another? Or is one independent of the other? What is the predicted pressure at 0 degrees Celsius? How about 100 degrees Celsius? So those are, you're going to have to know the slope to calculate those. If the gas is in a closed in an enclosed container, why would the pressure go up with the temperature? Consider what is happening to the molecules. So remember what happens to molecules between solid, liquid, and gas states. What do we know happens to those molecules to change how they are arranged and interacting? That we could potentially also explain why an increase in pressure. And then that's it, because the next thing is APA formatting. If you're more comfortable with MLA, I'm not going to be super upset if you use MLA. That's okay. It's basically, it's going to be, we're not going to go into tons of depth with APA formatting. We're just going to do a reference list where you do the author, the date of publication, the title of the work, and then most likely the source, which will probably be a website. And then you would have an in-text citation, which will probably be parenthetical. Most of the time, the author is not mentioned. Most of the time, we summarize information without mentioning the author. And so we just put the author and the year in parentheses at the very end. And then you'll get a grade on organization and grammar. Do revisit the website or the homepage and the announcements for the AI policy. Reach out for questions if you're concerned on your AI use. The cool thing is we do get the opportunity to explore using some of the AI that is available to us. And the more we do explore with it, the more you're going to learn about ethical use. And then when you get into the workforce and you're using it, because we're in the day and age where it's going to be used, you'll know how to appropriately use it and not. So, but that also comes with a learning curve, right? So ask questions, reach out. I think I skipped over this part. Each question will be graded based on this rubric, just so you know. So each of these categories, each question will be given a grade 0 to 3. All right, that's it. So let me know.